All right, week 5 worksheet part 2. This first one, I don't think I'm going to really work it out. I left it in here. It's a week 4 problem, but I put it in here because I want you to think about it when you're doing problem 2 down here. Really what's going on in this problem is that we're throwing a ball out of my window. It goes up, comes back down, and hits the ground. So if we let time be on this axis over here and the height be on this vertical axis, what's going on is that at time 0, the ball is in my hand at my office, and then I throw it up, reaches some point, turns around, starts coming down, and eventually hits the ground here. Meant for that to be a little smoother, but whatever. And we got kind of a parabola shape here. But what I want to point out is that the height right here is 25. That is h of 0 equals 25. And the height at the end here is 0, right? It's when the ball hits the ground. But the question is, how far has it traveled by the time it hits the ground? Your answer wouldn't just be the height at the end minus the height at the start, right? Or the height at the start minus the height at the end. It's not just 25 minus 0. This ball's gone a lot further than 25 feet, right? The net distance that it's traveled is negative 25, right? It's gone from 25 down to 0. But the total distance it's traveled is a lot bigger. It went up to some point and then back down. So to figure out the total distance, we'll first have to figure out how far it went from 25 up to whatever its highest point is up here. And then we'll have to add to that how far it went going down from its highest point down to the ground. And the way we answered this problem in week 4 is one special property that this highest point has is that the derivative at the apex here is equal to 0. That is h prime of t star maybe equals 0, where this right here is t star, this special t that its derivative is equal to 0. So really the important thing to find is figure out when the derivative is equal to 0, and then we can figure out the total distance it traveled accordingly. So that's the strategy we're going to take on problem 2 down here. Problem 2, the position of a particle is given by this guy. What's the total distance that the particle has traveled from time 0 to time 5? So what I'm saying here is you can't just look at where it ends up, the position after 5 seconds, and subtract where it started out, the position after 0 seconds, the initial position. That won't be your answer because it might be going forward for a while, backwards for a while, then forward again for a while. Kind of like over here, we couldn't just do 25 minus 0 or 0 minus 25. We had to kind of look at some intermediate points. We had to look at where the position was changing directions. So that's what we're going to do down here. We'll have to examine where this particle is changing directions, where it's going from moving forward to backwards. And the property that it will have whenever it changes directions is that the derivative will be equal to 0. Right? If you're running forward and then you switch to running backwards, there's some instant in there where you're not moving at all. So to solve this, we figure out p prime of t. That is 3t squared minus 18t plus 24. Easy enough because it's just a parabola. And then we set this thing equal to 0 and solve. Right? We want to figure out when this thing equals 0. Don't plug in zeros for t, set it equal to 0. To solve this guy, I think the easiest way is to factor out a 3. Let's see, that's 6t and this is 8. And then hopefully this inside part factors. We want two numbers that multiply to positive 8, add to negative 6. I think negative 2 and negative 4 will do the trick. So what that's telling us is that when t equals 2 or when t equals 4, the speed of this particle is 0. This particle isn't moving. In other words, it might be switching direction from going forward to backwards. So the way we'll get the total distance that it traveled is first we'll figure out how far it traveled from between the initial time and time 2. I'll put these absolute value signs around this expression so that if it's going backwards, we don't end up with a negative number here. We want to add up all these distances. And then we want to add to that how far it traveled between times 2 and times 4. Right? We know it didn't turn around anywhere in that interval, so we'll just figure out the difference in those two. And then finally, we want to know up to time 5. So we'll have to add in the position at time 5 minus the position at time 4. And if you figure out all these guys and add them up, you'll get your answer. Seems like a lot of work. Maybe I'll just leave that for you guys to do. Some of them are easy, like all you're doing is taking whatever number is here and plugging it into this function. 0 isn't too bad, even 2 isn't terrible, but when you get to 4 and 5, it might be something you want a calculator for. So I'll just leave it at that. I'm not so concerned with the number that you come up with, but more that you understand how to do the method, that you understand why this makes sense as your answer. So maybe we'll just, instead of making that a sum, I'll just leave this as the answer. And then moving on. Our first linear approximation problem. So what happens with linear approximation is we sort of pretend that we don't know the height of a function at a certain point. So in this case, our function is the square root of x, and we don't know the height when x equals 9.03. But we do know the height when x equals 9, right? The square root of 9 is just 3. So we can figure out, we can estimate the height at 9.03 based on this knowledge of the height at 9. So what I'm saying is, maybe it's easier to understand this with the picture. Here's a graph of f of x equals the square root of x, and maybe here's 9 right here, and just slightly to the right of it is 9.03. And if we suppose for a second that we can't figure out this point right here, but we do know this point right here, what we can do is first figure out the equation of the tangent line at the point we know. So this first point right here, the equation of the tangent line at 9. And then to estimate this height, instead of taking the actual height at 9.03, we'll take the height of the tangent line at 9.03. So this right here, this red dot will be our answer. The blue dot is the right answer. So we're not getting the right answer, we're just getting an approximation. It's called linear approximation. So this is what we'll be doing. But it's not really anything we haven't done yet. We found this equation of the tangent line. We've done that plenty of times. But really now it's more thinking about kind of what that means and why that works as a decent approximation as long as the points are really close. Right? Since 9.03 is really close to 9, it's a decent approximation. But using this red line to estimate the blue line, it's not a great approximation when you get way out away from 9. So anyways, if we do the work, let's see, we got f of x equals the square root of x. And we want to find the equation of the tangent line at 9. We'll start by finding f prime of x. Done this a few times. 1 over 2 root x. Move the 1/2 down in front, negative 1/2, switch those back to square roots. So you get f prime of 9 is equal to 1 over 2 root 9, which is 1 over 2 times 3, which is 6. So this right here is our slope. And then if you do y minus y1, when x equals 9, our y is equal to 3, equals m times x minus x1. We can figure out the equation of the tangent line. Let's see, 1/6 times 9 is 9/6, which is 3/2. And then if you add 3, you get y equals 1/6 x plus 3 is the same as 6/2. So 6/2 plus 3/2 is plus 6/2 minus 3/2 is positive 3/2. So this right here is the equation of the tangent line to this blue function at this point 9. So this right here is the equation of this red line right here. And this red line is what we're going to use to estimate this height 9.03. So our estimate, this is often written as L of 9.03. This just means the linear approximation at 9.03. So this isn't an exact answer, and it's approximation. That's what this L stands for here. Would be 1/6 times 9.03 plus, this is supposed to be 3/2 here, 3/2. And whatever this number is a pretty good estimate of what the square root of 9.03 is. It's not exact, it's this red dot instead of blue dot, but that's the idea of linear approximation that you'll do a lot on your homework. And this last question, I took this right off a quiz from last quarter to kind of give you an idea of the difficulty level from the quiz. It's actually a related rates question. What's going on here is we're given that intelligence, which is I, is related to the length of one's beard, B, by this formula. So we have a formula, 2 times the natural log of I equals B over I. And what we want is the rate of change. We want I prime, so that's our hint telling us that I is a function, and we want it in terms of I, B, and B prime, so B is also a function. So what we want to do is take the derivative of both sides of this equation, treat I like a function and treat B like a function. If we do all that, there's really 2 ways to do it. Maybe I'll do it the harder way and leave an easier way for you. One way that might make this easier, if you don't really like the quotient rule, is multiply this I over to the other side right at the start. So maybe I'll write this up in red. Another way to approach this problem is to think about it as 2 times I times natural log of I equals B. And then use implicit differentiation on this guy. You got a constant, and then a product rule, and then this guy's just off by itself. But it'll end up being a little bit easier, and you should get an equivalent answer. If we take the derivative over here, leave the 2 alone because it's a constant. The derivative of natural log of I is 1 over I. But be careful you're not done. Chain rule. Outside function is natural log of x. Inside function is I. So we get I prime. And that's equal to the derivative of b over I. Using our product rule, we got b prime I minus bi prime. Sorry, this is the quotient rule. Over I squared. Then we want to solve this thing. We want to solve for I prime. So let's see, maybe multiply both sides by I squared to get rid of the fraction. That'll give you I squared over I on this side, which is just I prime. And then on this side, you got b prime I minus b I prime. And now we're at a point where we can get all the I primes on the same side of the equation. Go up here, you got 2I prime, add this term to the left-hand side, plus b I prime equals b prime I. Factor out an I prime. And solve for I prime, which gives us this answer here. So if you do it this way, this is the answer you end up getting. This is equivalent to this, even if they don't look the same. If you solve for b and use the relationship that we have here, you can get from one to the other. I won't bother doing that. It's just an algebra exercise. But just in case you wanted to do it this way, I wanted you to have the answer handy here. And finally, that brings us to the last part. It says, at what rate is one's intelligence changing? That is, find I prime if I equals e squared. I prime is what we want to know. And beard is growing at a rate of, so they're giving us b prime equals 24. I want to point out that they did not give us b, but we can figure out b because we know I and we have this equation here. So we know that 2 times the natural log of I is going to equal b over I. So if I equals e squared, you get 2 times the natural log of e squared equals b over e squared. Natural log of e squared is just 2. 2 times 2 is 4. So you get 4 equals b over e squared, or b equals 4 e squared. So a little bit of algebra, you can figure out what goes here. And then once you have these pieces, we can just plug them into our answer up here. Maybe I'll change colors using all this stuff. We plug in up here and get our answer to part B is, instead of B prime, we'll write 24. Instead of I, we'll write E squared. And then 2, instead of I again, we write E squared. And instead of B, we write 4E squared. And this is correct, but you can simplify a little bit. 2E squared plus 4E squared. 2 of something plus 4 of something is 6 of that something. So this is 24E squared over 6E squared. E squared's canceled. 24 over 6 is just 4. So the answer down here is just 4. The intelligence is changing at a rate of 4, whatever that means. One little correction in here before I finish these up. It looks like I dropped the prime. Right, we had B prime in this line and then just changed to B. It should be B prime here. So B prime in the answer. And then this is equivalent to this if you do enough algebra with it. The one thing that's interesting about this expression is there's no b's in it. So down here we weren't given b, we had to figure it out if we used this form of the answer. Over here we don't even need to figure out what b is because there are no b's in the answer. But now I think that is the end of the worksheet.